Right, we are working on 7.2.2 today. And this is all about rhombi. Kind of about rhombi, but there's really something else that I really need you guys to get out of this today. We are going to be looking at a rhombus and looking for properties of a rhombus. But the main thing you're going to get out of today is a way that we can expand on the proofs that we've been practicing. Okay, so that's the key thing that I need you to really understand. In the process of doing that, we're going to figure out some new properties of a rhombus. But the key idea today is how can we take a proof that looks like what we've done so far and how can we expand it out? Okay, so can you guys think back to the proofs that we did back in chapter 6? Chapter 6? Do you remember what those look like? How many of you still have your chapter 6 packet? I think with the bubbles, yeah. You still got those packets? You might want to have it out. Yeah, we were proving that triangles were congruent. First of all, can you remember the 5 ways that we can use to prove triangles congruent? SSS was one of them. Give me another one. SAS. What are the other 2? ASA. HL works for similarity, but not for congruence. I heard HL, we're missing one. AA works for similarity, but not for congruence. AA, and we need a side to go along with it also, AAS. Those were our 5. And remember when we made our proofs, typically our proofs would look something like this. We'd have 3 evidence bubbles, and then they lead into the conclusion that the 2 triangles were congruent. Does this look familiar to you at all? Do you feel confident that if I gave you a picture that had 2 triangles in it, you could put together a proof like this? Okay, if the answer is maybe, I'll take that. Probably after we go over this today, you're going to feel a lot more confident. If you're looking at this though, and you're like, I have no idea what that is, again, now is the time for you to get that fixed. Talk to me. We'll schedule a time you can meet with me before school or after school or at lunch. But if you can't remember how to do this, then what we're going to do today is going to be very difficult, because today we're actually going to take that and have some more bubbles coming off of it. And those are going to lead to even more bubbles. And this is what our proofs are going to start looking like from here on out. Okay. So we spent most of chapter 6 learning to do this portion of it. We're going to expand that today. And the key piece is this connection right here. The main thing that we're going to learn in our lesson today is how can we go from congruent triangles and expand that out to help us start dealing with things like quadrilaterals. Okay. So this is the big connection today. All right. So to get there, we're going to be working on problem number 61. And I'm going to walk you through parts A and B here. You're going to be doing parts C and D on your own. So I need you guys to be super attentive and ask me some good questions as we're going through here. All right, 61, you can read about Audrey there, but Audrey's working with the rhombus. We're definitely going to want to get those drawn in our notes. So go ahead and copy that down with me, please. And let's label our vertices P, Q, R, S. Mine does not look that much like a rhombus, but it's all right. So part A tells us to draw it. Part A also asks us to put some markings on there. Go ahead and read part A and put those markings that they're asking you for there. If you weren't here on Tuesday, we did definitions for some different quadrilaterals. What was the key part of the definition for a rhombus? Not parallel. All sides, 4 equal sides, 4 congruent sides. So they told us it's a rhombus, so we can go ahead and mark all 4 of these sides congruent. That's the definition of a rhombus. They tell me it's a rhombus, then I know for a fact that all those sides are equal. It doesn't really look like it the way I drew it, but aren't there also, oh, can you hold that thought for just a second? Don't lose it, okay? Hang on to that. No. All right. Part B. You don't even have to hold it for that long. Look at what part B says. Part B says, what else might be special about the sides of a rhombus? Make a conjecture. A conjecture, remember, is just an educated guess. Okay, so you don't have to be right here. I want you to make an educated guess about the sides. All right, that idea that you had in your pocket. You think that these sides are going to be parallel too? That's a good conjecture. Write that down for part B. Anybody else have any other conjectures? You don't have to write that one down if you got another idea. This is a conjecture. This is how math works. We're like, it seems like this should be true. So we make a guess and then we try and prove that it's true. And if we can prove it, then it is true. You think it's going to be, you're going to have two pairs of parallel sides here? That's what Parker said too. Anybody have anything else to say about the sides? We already know they're equal. We don't need to make a conjecture about that. We think they might be parallel also. All right. So my conjecture, I'm going to be very specific about it. Hey, don't, please, I need your attention today, okay? I'm going to be very specific about this. I'm going to name my two sides. I'm going to name this top side here PQ with the bar over it. What is the side that PQ is parallel to? SR, you could call it SR or RS. I'm going to write parallel to SR. Right, those are opposite sides that are parallel, which is what you just said a second ago. And can you write me another set of sides that would also be parallel? You said two sets of parallel sides. What would the other side be? Wonderful. Write that down. PS and QR. So we're doing what actual mathematicians do here today. We're looking at a situation. Let's put that in your bag, please. Thank you. We're looking at a situation. We're making an educated guess. This is a conjecture. I don't know that these are true. Actually, I'm going to put a little question mark over them. And we're going to try and prove that these two things are true. When we prove them, that's going to be the end of our proof. Okay, so that's what these two legs coming off the bottom of our proof are going to be. We're going to try and prove that these two things are parallel. That's going to go on our proof down here. All right, so let's look at part C. I'm going to pull my book here so you can see it on the screen, or you can look at it in front of you. This is kind of the key here. So Audrey knows congruent triangles. Remember, that was all chapter 6. Audrey knows congruent triangles can help prove other properties about quadrilaterals. That's what we did on Tuesday, right? We took two triangles, stuck them together, and made a quadrilateral and used that to prove some stuff. So Audrey's remembering that. And so she starts by creating triangles. She's going to add a diagonal PR to her diagram. Could you take your picture and draw a line from P to R? I'm not going to draw it on the book here because it's a book, but on your notes, can you draw that diagonal from P to R? So we're going to add that diagonal and then prove that the new triangles you created are congruent using a flowchart proof. So let me catch up to you here. Did y'all draw this line from P to R? All right, we got two triangles there now. So this is where I need you to go back to your knowledge from chapter 6, and I need you to create a flowchart proof that proves that these two triangles are congruent. Basically, you're going to do this thing that we did back in chapter 6. Okay, that's all you need to do for part C. And then in part D, you're going to add on to it. Okay, now we are not doing this together. Okay, sitting at your desk and waiting for me to put the proof up here so you can copy it down is not a viable option. Okay, I've said this before. You will never learn to do proofs if that's going to be your strategy. Okay, you've got to try it on your own. So I will not be putting the correct proof on the board here. However, I am going to walk around. I'm going to give you guys hints and answer questions. And I have provided some other resources because I know this class is really good about asking questions. And sometimes it's difficult for me to get around to everybody in a timely manner. So I got a backup plan for you. You're going to need to wait for that to come back. Please have a seat. I got a backup plan for you. I'm going to show you this on Canvas. So let me get out of here and go to my Canvas. If you scroll down to Thursday, I've created a document that says problem 61 hints. If you bring up this problem 61 hints, the very first page you're going to see is going to basically give you the format for the proof. Okay. If you scroll down, it's going to give you a little bit more information. If you keep, so each page has just a little bit more information. Now, could you just go to that and scroll to the end and copy the final proof down? Yeah. Are you going to learn anything by doing that? No, you won't. Okay. And if that's what you're going to do, then you're good luck on the test. Okay. I need you to try as much as you can on your own. Get my attention. Let me give you some hints. But if I'm busy helping someone else out and you're totally stuck, and the person sitting near, all the people sitting near you are also stuck, and you can't get a hint from anyone else, you can either go to Canvas and look at that hint document that I just showed you, or if you guys, you see over there by the window, there's a couple pieces of paper. One of those is a packet that has those hints printed out on it. I want that to stay over there, okay? If you need to go over and look at those hints in that packet, that's totally fine. You need to leave your notes on your desk though. You go over there, you take a peek at it, and then you come back to your desk and finish it. We're not copying, okay? Please do not just go and copy stuff. You're not gonna learn that way, okay? This is gonna be tough. It's gonna be a tough problem, but I believe in you guys, you can do it. So your job right now is to start with part C, create that proof that shows me that these two triangles are congruent. If you have your chapter 6 packet, congratulations on being an excellent student with good organizational skills. You might want to have that out to kind of give you a hint, because we did a lot of proofs like this in chapter 6. If not, see if you can borrow some notes from someone else or get my attention and I'll help you out. Okay, so your job is to finish up C and then move on to D. We will come back together in about 20 minutes or so and talk about these together. If you do finish both of those, feel free to get started on your assignment, which is the next one that's listed on your packet. Any questions about what we're doing? We are going to put together the biggest proof that we've ever done in this class today. You guys are going to all be successful with it. Okay. All right. I'll be around to give you some support here in a minute. Let's get after it. All right, folks. Hey, I'd love your attention, please. So please wrap up wherever you're at right now. And I want to talk about C and D. Now, I told you I wasn't going to sit up here and do the whole proof, and I'm not going to. So I'm not going back on my word here. Can you guys please give me your attention? Stop the chat. Thanks. It seemed like everybody was doing a pretty good job setting up their proof to prove the two triangles congruent. I'm not going to fill in the bubbles. I'm just going to draw them so we know what we're looking at here. This is the part, though, that if you're having any trouble with this, you're going to want to get some help. Okay, just see me and we can set up a time. What you end up doing here is proving that one triangle is congruent to another triangle, and SSS congruence was the reason. And I think just about everybody was able to get that portion of it done, and that's awesome. So remember what I told you, our key was, how can we then use this to start talking about quadrilaterals? This is the big thing right now, by the way, okay? So if you're working on homework right now, I want you to stop and pause and pay attention, because this is the reason why we're doing this today, okay? The big idea is, once I have proven that these two triangles are congruent, which we did here, then I can start saying stuff about the other parts of these triangles. These triangles, we already knew about all three sides. Those ended up in our evidence bubbles. However, there are some angles that were not marked in this that once I've gotten to this step in my proof, I can start marking. For example, this angle and this angle are congruent. Why are they congruent? They're not congruent because of alternate interior. No, they're congruent because they're matching parts of two triangles that I just proved were congruent. Okay. They do happen to be alternate interior, but that's not why they're congruent. They're congruent because you already showed me these two triangles were the same, so their parts have to be the same also. So I can come off of this and create a new bubble. I'm going to name this one up here. And if you haven't done this, go ahead and do it with me right now. I'm going to call this angle up here QPR. And I'm going to call this one down here SRP. And this is our new reason that we're learning today. This is the big thing for today. The big idea is that if I have congruent triangles, that leads me to congruent parts. So congruent triangles lead to congruent parts. All right, this is our new reason. We're going to be using this a lot. It's always going to happen after the triangles are already proved. Okay, once we got the triangles proved, then we're going to use this to start talking about some of the other parts of the triangle. So the triangles actually lead into this. So we could go back and find some other angles that would be equal. I'll leave that to you. Well, I ended up doing this pair of angles also. We'll come back to that though. But check it out. Guys, look up here for a sec. Let's see if I can find, do I have a marker? Don't. I'll just highlight it. Remember that Z shape we were talking about with our alternate interior angles before? For these purple angles that I marked, this is the Z shape that I'm seeing. You see it? So these angles right here, they are alternate interior angles. And what we learned back in chapter 2 was that if you had alternate interior angles and they were congruent, which we just said they were, what's that mean about these two lines? They're parallel. So from there, we come off of this and we say that the top of our shape, which was PQ, is parallel to the bottom of our shape, which is SR. And that's one of our conjectures that we were trying to prove. That bubble comes off of the angles, and our reason for this is alternate interior. All right, we would have another bubble coming off of this that would also be angles, and then we'd have another bubble coming off of this that would also be some sides that are parallel. It's not super important to me right now that you've got all the details filled in. What I'm really interested in right now is, do you understand the big concept, which is once we have the triangles congruent, then we can start using that to talk about parts. Okay. Can I get you guys to turn in your packets right now? Let's find a good spot for this. Do we have an other notes section of our packet? Oh my goodness, we do, don't we? Other notes. I'm going to put this right in here because this is important. I'm going to put it right up top so I've got lots of room. I'm trying to use my space really well here. Let's do it right here. Congruent triangles lead to congruent parts. Congruent triangles lead to congruent parts. And I'm going to make myself a note. So this is going to be our new reason that we're going to be using a lot. Thank you. And we use this after you prove the triangles congruent. I'm going to draw myself a little example right here. Let's say I have triangle ABC congruent to triangle DEF. ABC congruent to triangle DEF. I'm not even drawing a picture here. I'm just kind of going to make a little piece of a proof bubble. So this would be like one of our old style proofs where we had evidence coming into this to prove it. Maybe we got to this using SAS. I don't even know. It doesn't really matter. Whatever that reason was. Once I knew this, then I could come off of this and I could start talking about the parts of those two triangles. For example, I could say that side AB was congruent to side what? You guys tell me. We don't have a picture. Can you tell me what AB is congruent to? It's got to be DE because why? Because the order has to match, right? So if A and B, that would match up with D and E. So I could use the congruent triangles to say that those parts are congruent, and my reason here would be congruent triangles lead to congruent parts. There is. If you would like a smaller way, I can show you a smaller way. Are you interested? It's called CPCTC. CPCTC. Sure. If you can tell me what it stands for. You're close. First two are good. Congruent. Congruent. Ooh, man, let me try and spell correctly. Congruent. Congruent parts. There's an of in here. Of. So congruent parts of, what do you think the CT stands? Of congruent triangles. And then we squeeze an R in here also. Congruent parts of congruent triangles are congruent. I actually messed this up. I'm sorry, guys. That first word is not congruent. It's corresponding. Thank you. Corresponding parts of congruent triangles are congruent. I totally biffed that. My bad. Thank you for your patience. Corresponding parts of congruent triangles are congruent. Does that make sense? Corresponding means matching. So basically, if you have congruent triangles, then their matching parts are also congruent. CPCTC. If you would prefer to use CPCTC, I'm okay with that. I don't think your textbook is ever going to use CPCTC. They use this, but it means the same thing. I'm fine with it. Yeah, I know what it means. If you do use it on a test, though, I might ask you what it stands for. You better be able to tell me corresponding parts of congruent triangles are congruent. See, I would have failed that just a second ago. I would have got a 4 out of 5 because I had the wrong word for the first one. All right, that's the big thing for today. Okay, so we are moving forward from just simple proofs where we prove the triangle's congruent. We're going to do that as a first step, and then from there we're going to use that to prove other stuff. That's our big thing for today. That's what I got for you guys. We got about 10 minutes left in the period. Our next assignment is going to be the 7.2.2 review preview. Let's use our last 10 minutes to at least start looking this over. If you have any questions about anything that we talked about today, please get my attention. We'll go over those. Let me stop my recording and get this up on the YouTubes for all our absent folks.